Okay, in this part we're going to look at our trigonometric integrals. Which are the integrals that take on the form sine raised to the m power of x, cosine raised to the n power of x with respect to x. And again, you should have a printout that shows you all the rules for each and every one of these. So what I'm going to do is I'm going to do a couple of examples for you here. I'm going to start with probably one of the more basics, and it doesn't matter whether you have the sine as your odd function or the cosine as your odd function. They still should work the same. Let's look at the integral of the sine squared of x cosine cubed of x with respect to x. And so let's go through the process. And of course, when I look at this, this does not fit a basic rule because no basic rules have both sines and cosines in it. And there's absolutely no way to really do any kind of distributions on this to turn it into anything that we actually can integrate. But we do have this trigonometric form here. And I notice that the power on the cosine function is actually odd. And when the power on either the sine or the cosine function is odd, we work it the same way. We're going to start by saving one of those things to the very end. So I'm going to have the sine squared of x times the cosine squared of x, all times the cosine of x with respect to x. So I just moved one to save it to the end. I am then going to convert the remaining cosines using the fact that the sine squared of x plus the cosine squared of x is equal to 1. Solving that for cosine squared of x, I get that the cosine squared of x is equal to 1 minus the sine squared of x. And we're going to take that and we're going to replace it back into our equation where we have the sine of x. Sorry about moving that around there. So then this becomes the integral of the sine squared of x. Instead of cosine squared, I'm going to put in the 1 minus the sine squared of x, all times the cosine of x dx. Now at this point I need to multiply everything out. I'm going to start by distributing through that sine function. So I get the integral of the sine squared of x minus the sine fourth power of x, all times the cosine of x dx. I will then go ahead and distribute that through, and I'm going to split this up into two integrals while I'm doing it. And so I get the integral of the sine squared of x cosine of x dx minus the integral of sine fourth power of x cosine of x dx. And in both of these cases, I can see that what I have is a u substitution. U is going to be equal to the sine of x. And so then the u prime is going to be cosine of x. This first one simply becomes u squared times u prime, and this next one is a u to the fourth times u prime. Of course, when we integrate u squared times u prime, we're going to get 1/3 u cubed, or 1/3 sine cubed of x, minus, when we integrate u to the fourth times u prime, we're going to get 1/5 u to the fifth, or 1/5 sine fifth power of x, all plus c. Now this process works the same regardless of which one of those have the odd power. If they both have an odd power, you can pick and choose. Whichever form you do, you're going to take one of the ones that have an odd power, you're going to save one to the end and convert the rest. Now in our next example, we're going to look at an example where the power on the sine and the cosine function are even. For example, let's look at the integral of the sine squared of x times the cosine squared of x with respect to x. And notice here that both the sine and the cosine are even. And when that is the case, we're going to replace them using the double angle formulas. And the double angle formulas say that the sine squared of x will be equal to 1 minus the cosine of 2x over 2. And the cosine squared of x is going to be 1 plus the cosine of 2x over 2. Okay. Now, when I look at this, you have several ways you can do this. I'd like to pull out the numbers. There is a number associated with this first thing here, and it's actually a 1/2, and there's a 1/2 associated with this as well. So I'm going to rewrite this as 1/4 times the integral of 1 minus the cosine of 2x times 1 plus the cosine of 2x. And I just like doing that because it makes it a little bit easier for me to look at. Now I need to go ahead and multiply this through. So this is going to give me then, when I multiply 1 times 1, I get 1. These are actually conjugates. So when you multiply here, the outer you get a positive cosine of 2x, and the inner gives you a negative cosine of 2x. And a positive and a negative are going to cancel each other out. And then I simply multiply the last, and I get a negative cosine squared of 2x, all with respect to x. And of course, this represents two separate integrals, and I'll write them that way. I'm going to get 1/4 times the integral of 1 times dx minus 1/4 times the integral of the cosine squared of 2x with respect to x. And then let's go through and do the integration on both. Starting with the first one, I've got just